Thank you so much. Today I'm going to talk about AI for civil environmental engineering at NUCEE. A lot of things have been said about AI that is driving, 99.9% of the economy, that college students are all flocking there. These are all this year. That it is, some of it is, some of it is not. A hype cycle, this is by Gartner. And the godfather of Meta's AI thing that the AI boom is over. Business Insider. Well, prediction is difficult, as they say, especially if it is about the future. With that, let us talk about my work a little bit and what gives me, what makes me think that I can talk about things here. By the way, I have this recorded because I am right now in Kolkata, India. Hi, I'm still here and I'll be here during the panel and the Q&A, but just wanted this part to be recorded so that just in case of any disruption. So my work at the top, from the science and engineering side, is climate adaptation and resilient engineering. I have these three articles here from Newsweek, New York Times, and Lifeware. I'm a very egotistical person. I have these three because they quoted me on these three. Anyway, so here is the science and engineering, and then how I do it, that's below. That's physics, human, data systems. And so I call this Care with PhDs. So we have had our share of, quotes in Nature Science, going to journals and conferences from ASC to ACM. ACM is the computer science one. For computer science, as you know, they care more about conferences than anything else. My home conference there would be KDD and an ASC and AGU and AMS, the usual ones. And then, of course, we have had some success in terms of translational research, such as startups. I'll talk more about that. Anyway, here is my research. These are some of the papers or some of the journals in which my papers have been published. At the top left, that's where that's where we have had some highlights and quotes, among others. So we have had highlights and quotes in Nature and Science when we talk about adaptation to a changing climate. This is climate science at the interface. This is primarily climate adaptation science. So it's the science is engineering sciences in civil environmental. Of course, you see a little bit of focus or a skewness in hydrology and meteorology, areas of my training, primarily hydrology, but also transportation. We have gone a little bit into that, but also some interesting work in ecology, marine science, and policy. One question in civil that arises is, are the disciplines developed during, I don't know, 15th, 12th, whatever centuries in Europe, are those disciplinary boundaries enough for us to be able to solve the societal challenges of this century and beyond? And where do we draw the lines to make a discipline civil? As they say, if you have to be an engineer, why not at least be civil? Versus uncivil, and say, well, we don't care for those. Should we do that? The similar or same approaches arises when you talk about big data and small data. These are two big divisions that I often talk about in data sciences. Machine learning in general requires big data, large data sets, versus certain things that hydrologists have developed, for example, with statisticians, is extreme value theory, and which is clearly falls into the small data domain. And then, of course, we have small samples. So if you think of big data, we think about generative AI, this paper that I just highlighted, where we got this stakeholder testimonial. This was in one Nature partner journal. And then in Nature Communications, computer vision, which helped us understand with explainable deep learning insights on El Nino and river flows. Generative AI, computer vision. TJ himself started some of this work in our lab when he used computer vision approaches, specifically super resolution, to tackle the problem of downscaling, for example. So machine learning, AI, generative AI, big data. But then extreme value, whether it's tail dependence, such as heat and dryness, whether it's extracting extremes in an intelligent way from large ensembles, still extremes, rare events. Similarly, with small data samples like nonlinear dependence or causality, extracting that in a robust way from small samples. These are papers in, for example, we have had in Physical Review E, and also in geophysical research letters for their applications. Very interesting work which have received a lot of attention. So different kinds of big data, small data challenges. And then we have network science, network engineering, which talks about interconnected systems. Again, where do we draw the line between calling certain things as data sciences and certain things AI? Is there a line? Should we only call these big data challenges AI, and maybe some of them should we call the small data challenges something else, or is it all a broad definition of data sciences with AI as one of the things that we do? Here is on the left, here is a history of AI. This I just took from some, I think, Medium. AI winters and summers, meaning visibility goes through various ups and downs. When I started my PhD, I was somewhere here, late 1990s, early 2000. This was my work with my advisor on precipitation nowcasting, short-term precipitation forecasting. And this had AI as one of the approaches. This had physics, so it was joint physics AI. 2003, it was published. And then last year, we had this work, which was published. The first author was my PhD student, Kate Duffy and Thomas Vandal, TJ. They were co-authors along with, so this work is where we co-designed a solution together with Tennessee Valley Authority, funded by NASA. I have just spoken about this earlier. Again, same precipitation nowcasting, again, hybrid physics AI, 2024. So a couple of decades have passed since then. And at the top left, if you look now, this history of AI, I can call it a personal history of AI in precipitation nowcasting. Going from there to just nowcasting and AI a little bit, and talking about this big data, little data challenges. This paper was published in Nature, Mother Nature. There are so many different natures now. This was called DGMR, Deep Generative Models of Radar, and Google made it a point to say that this is physics-free. They said that this outperforms the state of the art, but it didn't work too well for extremes or for convection. And extremes are rare events, remember, so small data. So they seem to work well in general, but not for extremes. And then when in 2023, another paper came up also in Mother Nature, this one by Xinghua and UC Berkeley, they outperformed DGMR. And they were better for extremes and convection. But what they did is, instead of the physics-free approach from Google on the left, this one on the right, they were physics conditional deep generative model, meaning they embedded basic physics like continuity equation into their models. Now, this was untested for hydrologic applications. So that's what we come in. And sort of we made this a little bit, I mean, we can say trustworthy. We got the stakeholder testimonial, implemented this in Tennessee Valley Authority region. And then we say, and then also adapted it and developed certain metrics that the TVA stakeholders cared about. So overall, making the process trustworthy. But again, hybrid physics AI, the point is for extremes where there are limited data, small data, little data challenge, hybrid physics AI works better. Now, this is one case. Does it generalize? Well, hard to say. Will TJ agree with me when I say that at least for extremes, physics, embedding physics into AI works better? I don't think so. Anyway, so let me talk a bit about our translational work. So we have had very good success, for example, with startups. This was urban climate risk was the focus, and the solutions were physics data models. And this company, as you know, this is Risk, which was sold to Intercontinental Exchange, which owns the New York Stock Exchange. And then TJ himself and Kate Duffy, they started this company called Zeus AI, which is still operational, running very well. And this is weather and AI. And then Udit Bhatia, who is now a professor at IIT, he started this flood prediction, physics plus AI flood prediction and flood resilience company. And then Jack Watson, who just defended his dissertation, started his company Enodia on resilience of installations, which handles the infrastructural ecosystem that surrounds the installation. So overall, 5 PhD students, 4 startups, many in AI, some in AI plus data sciences, some in data sciences. Again, I don't know how to exactly divide that. Like I was saying here, sorry to take you back a little bit, but where do we draw the line between data science and AI? It's not very clear to me. So I'm going back. Hopefully this will refresh your mind on some of these things. And with that, just that one PhD student, Evan, who had this first company, an incredible journey from publishing an interesting counterintuitive paper, which got a whole highlight in the journal Nature, to starting his own company, which was made into an article by the Wall Street Journal. So incredible journey. We have to think carefully now about balancing what we want to do with civil engineering, where these disciplinary intersections are, and where the AI landscape intersects. And I'd like to end by pointing to the Institute for Experiential AI, where I think we should build more connections with. In fact, I lead AI Forecast, AI for Climate and Sustainability. This is the third of the 3 focus areas shown here. And just to highlight, this is big deal. There is this whole Genesis mission for AI from this White House. With that, thank you very much.